Welcome to In 5 Minutes. Today in this presentation we will see what are actually the preset and clear terminals in an SR flip-flop. So here is the actual diagram what we see in the last session of SR flip-flop. Now what are actually preset and clear terminals? Preset and clear terminals are nothing but the third input to the NAND latch. This is called as preset and clear terminal. As they are shown, they are the external inputs. Why they are called as external inputs or the direct inputs to the SR flip-flop? Why? Because they are not connected in synchronization with the clock pulse. Since S and R, these are the inputs to the SR flip-flop in synchronization with the clock, where preset and clear are not in synchronization with the clock. Whenever you want to apply the preset and clear, they are applied in between clock pulses, hence they are called as direct inputs, not synchronized with clock. What this signifies, this is important. If preset is equal to 0, this implies that directly Q will be equal to 1, that is nothing but the set position. That is nothing but flip-flop is set. And if clear terminal is kept 0, that will set Q bar equal to 1, that is nothing but reset condition. So you can directly set and directly reset a flip-flop. Let us say that the power is on, then you don't know what is the previous state of the flip-flop. Then if you want to start it from direct set condition or direct reset condition, you don't know what is the initial stored value. In that case, before applying the first input with the first clock pulse, you will apply a negative pulse at PR that will directly set the flip-flop, and a negative pulse at clear if you want to directly reset the flip-flop before starting your operation. Let us see how this preset and clear terminal works in a tabular manner, input and output wise. So here our inputs are preset, clear, clock pulse, inputs S and R, and depending upon the SR input, what will be the output Qn plus 1. So if I will try to set preset and clear, let us say they are both are 0. Clock is absent. There is no matter what the position of S and R are, because S and R will be triggered along with the clock. If clock is don't care, S and R also be don't care. So if preset and clear, both the inputs, both the external inputs to the NAND latch are 0, then definitely Qn will also try to become 0 along with Qn bar. So there will be a race condition. So this state we named it as race. Let us try to put PR is equal to 0. This condition will directly set the flip-flop. This will directly reset the flip-flop. In this case, suppose preset and clear both the terminals are kept at logic high level, clock pulse is absent, irrespective of the inputs, then this whole circuit will work as a memory cell, hence it will show the previous state, that is nothing but Qn. So this will be termed as previous state. Again, in the next 4 condition, if we will put P and R continuously 1 and the clock pulse is present. So these 4 conditions are nothing but the combinations of S and R, that is nothing but 0 0 0 1 1 0 1 1. Now you need to work it on with the basis of how the SR flip-flop works. See, when SR is 0 0, gives us previous state. So again here will be output is equal to previous state. In this all the 4 cases, preset and clear terminals are kept at logic high level. So the output of the NAND latch cannot be implemented or cannot be directly set, because one of the input of NAND gate is 0, then only the output is predicted as 1. Here both the inputs are 1, so you cannot predict. That's why when SR flip-flop is 0 1, it will reset the flip-flop. Since S bit is 0, so this will be a reset condition and output Qn plus 1 will be equal to 0. Next case, SR is 1 0, that will be a set condition, that is equal to Qn plus 1 is equal to 1, and 1 1 state, again it is a race condition. Why again 1 1 is race condition? Because if you will apply S and R 1 1 with the clock is equal to 1, so clock is also 1, so these outputs will be 0 0. Now no matter what preset and clear are, one of the input to the NAND latch is 0 in both the sides, at the preset terminal also, at clear terminal also. Therefore Qn and Qn bar both will try to become 1, hence there is a rest condition.